Hi everyone, this is Mrs. Musoff. Today we're going to talk about geometric probability. So I have the definition written down here. So go ahead and copy this down into your notes. For geometric probability, we're talking about area. So that means we're going to be finding the area of a given region and dividing it by our total area, or our largest area will be usually the case. Okay, now in some cases, that means we have to use our area formulas, but sometimes you can get a problem where you can break it up into similar shapes, and that can allow you to calculate the probability a little bit easier. So let's try those problems first. All right, in number 1, it says a dart is randomly thrown at the dartboard. Determine the probabilities. And the hint is to first make the circle 8 even pieces. All right, so before we talk about that hint, just take a look at that circle. Just based on the way those regions are separated, does it look like there's the same probability to hit C as there is to hit D? Hopefully you're thinking no, because D has an area that's much smaller than the area of C. So when we aren't necessarily sure of how to find the area of these shapes, one thing that can help us is if we can break the shapes up into the same size pieces. Then we can just count those pieces and use that to determine probability. So let's try to do that here. All right, when it comes to breaking it up into even pieces, we usually base it off of the smallest piece. So hopefully you can look at this and see our smallest piece is D. And one thing that's going to help you before you break it up is if you give yourself an idea as to which region each letter represents. So I'm going to do that by kind of coloring them in. I'm going to color region A is the green, region B is blue, region D is purple, and D will be yellow and C will be purple. Okay. So now when it comes time to splitting them up into even pieces, I'm going to look at my smallest piece, which is D, and I'm going to try and make all of these, break them up into that size. So for B, for example, I can tell that if I were to cut it in half, it'll be the same size as D, so I'm going to draw that line cutting it in half. Now these two pieces are still both B, alright, but now I can see there's 2 of them to just 1 of D. Alright, same thing with A. I can break up A by cutting it in half, and I'm just going to write A in both of those pieces. So again, A also has 2 pieces. C is a little bit trickier, but we can break it up if we extend this line going down. This side is C, and then if I split this one in half, I've got 2 of them here. Okay, so now that they're all the same sizes, we can find that probability a lot easier, just by counting up how many of each piece there is. So for example, probability of D, I'm going to count up how many pieces of D there are, which is just 1. And I'm going to divide it by the total number of pieces that I have. And here there are 1, 2, 3, 4, 5, 6, 7, 8 in total. Alright, so my probability would be 1 out of 8. If the problem asks for a decimal, then I would take out my calculator and just divide 1 divided by 8, which is 0.125. And if the problem asks for a percentage, I would take that decimal and multiply it by 100. Okay, which would be 12.5%, or if the problem said to round, you could write 13. Okay, I'm going to write 12.5%. But that's the idea. Alright, so same thing for the next one. Probability of C, I'm going to count up how many pieces there are for C, 1, 2, 3, and put that out of the total. So 3 of the 8 pieces are going to represent C. And this works because they're all the same size. If they were different sizes, we couldn't do it this way. But since I was able to break them up into the same size, we can just count it out. Okay. And once again, if you wanted the decimal, we would just divide it. 3 divided by 8, 0.375. And if we wanted the percentage, we would just multiply by 100. That would be 37.5%. You don't have to give me all 3 of these answers, but I just want to make sure you're able to find them depending on what the direction's asking for. Okay, number 3, the probability of B or C. So or, when we're talking about probability, means you're going to add up those options. So there are 2 of B and 3 of C. So if it's B or C, I would do 2 plus 3 out of the total 8. So that would be 5 out of 8. Alright, this symbol right here, remember that means the probability of not C. So usually when it's not a certain one, I like to take my total and subtract that region out. So I would take my total 8 pieces and subtract how many there are of C, which would be 3. All right, so that would mean, 8 minus 3, that would give me 5, so it would be 5 out of 8. Okay, probability of not A, again, same thing. Take my total, subtract the 2 that are A, that would be 6, so it would be 6 out of 8. Now that one can reduce, so I'm going to reduce it to 3/4. Okay, last one, A or B, I'm going to count up A, that's 2, and B, that's 2, and that's going to be 4 out of 8, which is 1/2. Alright, and that's how we do some of these geometric probability ones. So let's try it again one more time, just to be sure. Again, given the dartboard below, find the following probabilities of a randomly thrown dart hitting the board. Hint, first make the rectangle 8 even pieces. So again, right now, if I were to do probability, the proportions would be way off. There's way more of D than there are of B. There's way more of B than there are of A or C. So I'm going to try and make them all the same size. So I look at my smallest size, which is the A or C. I'm going to color them in just so I don't get too confused when I start splitting them up. And then I'm going to start chopping it up. So one thing I like to do is just continue the lines. Alright, that'll sometimes help you figure out how to break it up. But then when you think you're done, always ask yourself if they all look the same size, because they should be the same size when you're done. And right now it looks like these are still a lot bigger, so I'm going to cut it in half one more time. Alright, now when it says the probability of A or C, I can count up the pieces again. There's a total of 8. So A or C, that would be 1 plus 1, which is 2. So it would be 2 out of 8. Okay, now that does reduce. So I'm going to reduce it to 1/4. Okay, the probability of not A, so again, I like to take my total, subtract how many there are that are A. So that'd be 1. That would give me 7, so 7 out of 8. Probability of D, there are 4 D, so 4 out of 8, which is 1/2. And the probability of D or C, again, or means add, so I'm going to take 4 and add it to 1. That would be 5, so 5 out of 8. Alright, let's go ahead and flip the page over. On this second page, we're going to do a little bit before we continue geometry, a little bit of practice between the difference between and or. So first, let's just make sure we understand the concept. We got 9 total boxes here, and they all have a letter and then a design. So for 11, it says the probability you choose a dotted one of these boxes. Well, there are 3 dotted ones out of 9. So 3 out of 9, or 1/3. Okay. Probability it's E. Well, there are 2 that are E out of the 9 total, so that would be 2 out of 9, and that doesn't reduce. And then the probability of it being a vowel, well, that would be E, this E, the A, and the I, so there are 4, so 4 out of 9. So now let's get to the part that's really important, and that's the difference between and or. When we think of and, we want to think of both of them happening simultaneously. Alright, so with and, there should be less options because you need 2 things to be going on, not just one. Okay, for or means it could be one or the other, so or is when you would add up all the different possibilities. Alright, so let's try it. In number 14, it says, what's the probability it's a vowel and dotted? So I'm going to look at my 9 options and figure out which one has both going on. For example, this one right here is E, but it's not dotted, so I wouldn't count that one. Alright, this one's not a vowel or dot, so I wouldn't count that. This one's not a vowel, I wouldn't count it. This one's dotted, but it's not a vowel, so I wouldn't count it. Right? And means both have to be happening. And eventually you should come across the ones that are both vowels and dotted. Only 2 of them here, so we would say 2 out of 9. Okay, now let me erase these marks so we can talk about or. Or means just one of them has to be true. So for this one, I would say, okay, this one is a vowel. It doesn't matter that it's not dotted because it said or, which means just one of them has to be true. So I would count it. Okay, this one, neither of them is true, neither of them is true. This one is a vowel and it happens to be dotted, so that means it's at least 1. Not a vowel or dotted. This one is dotted, so it counts. This one's a vowel, so it counts. not this one, and that one's a vowel and dotted. So you can see you have more options when it's or, because you're adding things together, right? We're adding up all these options. All right, so in this one, we would say there are 5 out of the 9. Okay, let's try it again with this other example. The probability it's white and a consonant. So that means only both. So what I like to do is kind of look just at the white ones and then figure out if either of those are also consonants. And in this case, both of them are. So I've got 2 out of my 9. Okay, let me erase. For or, again, just one of them has to be true. So I can circle the 2 that are white. And then out of the ones that are left, I can circle the ones that are also consonants. So that would be 5. So there'd be 5 out of 9. Alright, so again, keep in mind, and means both simultaneously, or means you can add up all the possibilities. For 18, the probability it's white, dotted, or vowel. Let me erase these. Well, white, dotted, or a vowel, that accounts for 7 of them. So we'd say 7 out of 9. And then for 19, consonant or vowel, well, this is a vowel, this is a consonant, consonant, vowel, consonant. One thing you should notice is every letter is either a consonant or a vowel, so this should be all 9 out of 9, or just 1. All right, last example. So this is the really important part of geometric probability. What happens when you can't break up a shape into equal pieces? Then we have to flash back to geometry and use our area formulas. So these are the 2 key formulas that you'd have to know. A circle is pi r squared, where r is the radius. And a rectangle is length times width. So for example, a stone is thrown at this weird board. The radius of the circle, that's this distance, is 9 centimeters. And the weird board has dimensions of 20 centimeters by 21 centimeters. I guess I kind of did that opposite. Let's do smallest first. So smallest is 20, biggest is 21. Well, first, the area of the circle. That part shouldn't be so bad. You just have to look at your area formula. Alright, area of a circle is pi times the radius squared. Well, our radius is 9. So I'd say pi times 9 squared, which is 81 pi, or you can type it in your calculator. Okay, 81 second caret, that's where pi is, second the caret button. So 254.47. Now, with area, the units are always units squared. So it'd be centimeters squared. Right. Area of the rectangle. Remember, an area for a rectangle is this formula right here, length times width. So I would do length, so 20 times 21. And that would give me 420. So 420. And again, same thing with units, centimeters squared. Okay. For 22, the probability the stone throw lands in the circle. Well, if I want it to land in the circle, then I'm going to do the area of the circle on top, because that's what I want to happen, divided by my total area on the bottom. Okay, area of the circle I know, because that's what we said in number 20, so 254.47. The total area, well, that's like the area of the biggest shape. So that is actually what we found in number 21, so 420. And I would type it into my calculator, so 254.47 divided by 420. I like to use the percentage. I think it makes it easier, so I'm going to times it by 100 and round it, so that would be 61%. Alright, last one, the probability the stone lands in the weird board but not the circle. Well, that's talking about like this region right here. Alright, lands in the weird board, not the circle. That's like everything minus what we just found. So I should just be able to take 100% and subtract out the 61% that we just found. Alright, so 39% it lands outside of the circle. Alright, that's it. If you have any questions, make sure you write them down.